Hi guys, I'm Darren, and in this video I'm going to show you an example of using the new custom OSD elements in INAV. So these elements have been added in INAV. I believe it was 7.1, it could have been 7.0, but these are really useful elements for if you want to add your own custom OSD data, which you can pull from all sorts of sensors and data using the programming tab. So for this example, I'm going to show something that's useful for me, may not be for a lot of people, but it should get you in the right area. Now, I'm a pilot in the UK. I fly using miles for distance and feet for altitude. It's just what I'm used to. I don't care about metric being better for calculations. I agree it is. It's just what I'm used to. I know how far a mile feels. I know how far the feet feel. It's my preference. But I often fly with people who use kilometres. So what I've done is added a couple of OSD elements. So I have the data in both miles and kilometers and feet and meters. So what I'm going to do is show you how I did that using the new custom OSD elements. So let's have a look at those first. So they're found in the OSD tab, unsurprisingly. So once this loads up, we'll come back. Right, so here we are on the OSD tab, and the bits we're interested in are on actually both sides of the screen. So first of all, let's show you how to enable and disable them. So we're going to go down on the left hand side, and we are looking for the global variables. Ideally, I think they should have probably been broken out into a separate category, because even though it's related to programming, it's not global variables. We maybe should just rename that to programming or something like that. But it's these here, custom element 1, 2, and 3. They're really useful. Maybe it's going to be worth adding more in the future. So it depends on people's use cases. If you find that you run out, please let us know and we can always add more. But at the moment, I'm just using 2. Now these are shown as CE_1 and CE_2. Now at the moment, that's not really too helpful. It would be nice if they actually showed the data that you're potentially showing and the number of characters that you're showing. It'll make it easier for positioning. So hopefully that's something that will change in the future. But at the moment, to adjust the alignment, you really need to sort of put it on the screen, look in your OSD, and then adjust it that way, which ideally we'll know exactly how big this is going to be, and we can adjust it on screen without having to look in the goggles. But at the moment, that is one of the limitations. So to actually set them up, we're looking on the right hand side, and you can see this custom OSD element area. And you can see I've already got 2 created at the moment, and they are for custom element 1, which is up here, and that is my distance from home in meters. And you can see here custom element 2, which is my altitude in meters. Sorry, distance from home is in kilometers. So how do we go about adding these things? Well, it's really simple. All you need to do is find out the data you want to add, and this, as I say, you get from the programming tab. We'll look at that in a sec. And then you just set up the custom element stuff here. Obviously you need to enable it on this side. So all these boxes basically have the same, apart from this one here, which is whether it's active all the time or whether it's active when a logic condition is set. I don't really get the global variable unless it's just 0 and 1, in which case you could probably just use a logic condition because you'll have that anyway. So I think in most cases it's going to be always on or based on a logic condition. The other 3 are all the same, and what you can set in here is text, a static icon, an icon from a global variable. So this is one of the 8 global variables, and you can actually set in there a number for the icon. So perhaps at one point you want an up arrow, you could give it the number for an up arrow. If you want a down arrow, you can give that global variable the number for the down arrow. So you can change that to change the icon as you need it. Same if you're doing some sort of rounding or whatever in the programming features, you could have meters at one point and then kilometers at another point. So it gives you that flexibility. The next one is global variable and then a set of digits. So with this one, you'll select the global variable number that you want, and it will be 5 digits as an integer. The next one, again, you select the global variable. It'll be 3 integer digits followed by 2 decimal point digits. Next one is just 3 integers. The final one is 1 integer and 1 decimal point. So for example, this one here would look like, trying to find one. Okay, no examples. Okay, so the bottom one here would look like this one here, be 1.6 for example. And what it will do is we'll pad it with spaces when there's no number present. So this one, if the number was 6.9, it'll be space 6.9, probably 6.90. So that's how they work out. And that's basically it. All of these are the same. So you just set them up as you want. And I'll give a better example of that in a minute. But first, let's head to the programming tab and see how we get the data. Right, so here we are in programming, and you can see I've already got it set up, and it's really, really simple. So all we're doing is getting the data we want. So for my first on-screen thing, I'm doing the home distance in kilometers. So that should actually be home distance, not 3D home distance. So let me change that because it's wrong. So home distance in meters. And for the first step, I'm actually dividing it. Now this divide depends on how you want it to display on screen. So if this is meters and we're just showing kilometers as whole numbers, then of course we'll divide this by 1,000. So 1,000 meters is 1 kilometer. But because I'm using 2 decimal places, I'm dividing it by 10. And the reason for this is in the programming tab, everything works with whole numbers. There's no floating point. So I'm doing 1,050 meters. So if I want that displayed as 1.05 kilometers, what I need to do is divide that by 10, which leaves 105. So following so far, and then the display will just add the decimal point 2 digits in from the end. So it's not a floating point calculation. And the same goes with the altitude. They're all sort of whole numbers, and you have to tweak the number you divide by to get the decimal places that you want, or even multiply, I guess, in some cases. So all we're doing here is doing a divide and a divide. So again, as our example, we got 1050 here. This will result in 105, which is what the status of the logic condition will be. The next one, we can skip this for now, is to set it in a global variable. So I'm using global variable 0, which is this one here, and I'm using logic condition here. So it's the result of this. So all this is doing is storing that 105 in global variable 0. That's all there is to it. It's really that simple. Logic condition 1 and 3 are doing the same thing, but related to altitude. You can see here the altitude is in centimeters. I'm just displaying this in meters with no decimal places, so I'm just dividing it by 100, because obviously 100 centimeters is 1 meter. And again, we're just setting that in global variable 1 this time, and using logic condition output 1. So I hope you can see how simple this can be. This could obviously be a lot more complicated. You could, for example, check for positive or negative numbers. If it's negative, you could set gvar2, for example, to be the icon for a down arrow. If it's positive, set gvar2 to be the icon for an up arrow. Then you can change the icon using that gvar thing. So let me just save this because I have actually made a change. And let's go back to the OSD page. Right, so now you know what the programming is doing, I can explain the custom OSD elements. So custom OSD element 1 is the distance from home, and it's in kilometers. So what we have here is a static icon, and that's 10. So this brings up the first question. How do we know what the icons are? Right, so here we are on GitHub, and this is the GitHub for INAV configurator. I'll put a link in the video description, but it's pretty simple. It's github.com/inavflight/inav-configurator. And what we're going to do is pop down to resources, and we're going to go in OSD. And in OSD, there is this character map.md file. So let's just click on that. And now you can see what the icons are. So what we're looking for is this decimal ID here. So if we look at 10, which is what we had in the OSD tab. So you can see here we've got static icon 10, and that equates to the house icon, so the home icon in this case. Next, I show the value in gvar 0, and if I click on this, you can see it is 3 digits plus 2 digits of decimal places. So this can go up to 999.99 kilometers. And after that, we're showing icon 126, which is the distance in kilometers icon. So that's how you build these things up. It's really that simple. And for the altitude, it's even more simple in this case. So I've got a global variable, which I've done to just 5 digits. I'm choosing GV1, which, as you remember on the programming tab, is the altitude in meters. And then finally, I'm showing icon 118, which is altitude in meters. So that's how you set these things up. It's really simple. As I mentioned, if you wanted to use the icon global variable, all you'd do is set the number in the global variable, which equates to the icon you want to use. So for example, there's up and down arrows near the top. You could use symbol 21 for an up arrow, 22 for a down arrow. There's lots and lots you could do. Let's go back to 118. So for example, we've got altitude meters, but you could then say if greater than 1,000, divide by 1,000, and then show altitude in kilometers and change the icon there. There's lots and lots of possibility with this stuff. So have a play. It's really useful, and it's a great addition. Like I say, it might be worth adding more of them, depends on how people use them. But yeah, I think this is a really fantastic thing. And to be honest, it may even be worth removing the switch indicators and just having 8 of these, because you can do everything that the switch indicator does with this. For example, let's replicate this one. So let's choose text, we'll call it flap. The next thing we need is an icon. So what we're going to do is let's set that to GV2. And for now, all we're going to do is save this. So what we have is the word flap. Oh, of course, we need to add it on screen. So that'll be there. So we'll just place that here, right underneath there. So we'll save that. Now everything is basically done in this tab. So let's pop it back to the programming tab. So now what we want to do is add this programming to change the icon on that switch. So I'm going to show 2 examples. The first we'll do for a 2-position switch. Now, if you're using a 3-way switch in the radio, you'll of course need to use a curve or something in the radio to make sure it only goes into 2 positions. The next example will be a 3-position switch, which will work exactly the same as the current switch position indicators in the OSD. So let's first get our switch. So let's say we want to get the high position, which is when our flaps are down. Now, this may sound backwards, but on the transmitter, if the switch is in the down position, it's usually actually outputting 100, which is actually the high number, which is 2000 microseconds. When it's in the middle, it's usually 0, which is 1500 microseconds. And when it's in the up position, it's usually minus 100, which works out to 1000 microseconds, which is the low position here. So if we want our switch down on the transmitter, we need to be checking high here. So we're going to check high, we're going to choose our RC channel, and we're going to say, we'll say it's on channel 10. Don't know what channel it would be on your system, but in this example, the flaps are on channel 10. So if we save that, it won't do anything, because if we look in the receiver tab, our channel 10 is just stuck in 1500. We've not actually got anything plugged into this at all for RC control. So back to programming, we now know where our switch is, or we now know when our switch is in the down position. So what we need to do is put the indicator in the OSD. So we're going to do set gvar. We're going to choose the value and 2, because we want to use global variable 2. And what we're going to do is set our value. So we want to go back to this page here and choose where we want it. Now it's up to you. You could choose to have the switch in the right place, or you can have it different. It's your call. So I'm going to choose to have it so that the switch looks like it's in the right place. So for this, we're going to choose 208. And what we need to do is set this so it's only active when logic condition 5 is enabled. So let's save that, and that would now work. Now, of course, this isn't active all the time. If our switch is not in that position, we still want to show something. So this is the example for a 2 position. So what we're going to do is choose a not, and we're going to choose logic condition 5. So when this is not true, this is true. So if I click save, you can see this one lights up because this one isn't. So obviously the switch is in the other position. So what we can do now is set the global variable, and we're using global variable 2, and we're going to set the value to 210, which if we look on here is the switch in the up position. And the final thing we need to do is make sure that this is only active when this logic condition is active. So we're going to set that to logic condition 7 and then save. So you can see gvar2 is actually 210 because that is the value we've got in here. Now this works for a 2-way switch or a 3-position switch where you've added a curve on the transmitter, so it's effectively 2 positions. But what if we want to check all 3 positions so it works the same as the current switch indicators? Again, this is really easy. All we're going to do is change the not to a mid. We'll set the RC channel to 10, and that's all we need to do here other than change this to 209. So now that is the middle switch indicator position. And we need to add our final one. So we need to do low this time. Again, get RC channel 10. And this one we're going to set gvar value 2, and this will be 210. And this needs to be logic condition 9, which is here. So if we save this now, you'll see this global variable has changed to 209 because it's in the middle position. And if we actually changed the switch position, we would see different values. So let's see if we can fake this. So if I change the RC channel in here, so let's do a override RC channel, set channel 10, and we'll give it 1000. See if we save that. You can see we're now at 210 because this RC channel here is low. And if I change that to 2000, it will change to 208 because the channel is high. So you can see that with the transmitter connected, that would actually work fine. So if we save it, go back to 209. So back in the OSD, what we've just set up now is exactly the same as using the switch indicators. So if I turn on switch indicator 1, that's set to flap. We'll set that on channel 10. Now where has it put it? There it is. So other than potentially the alignment, these two will both show exactly the same thing now. And of course, if you wanted to reverse the side the element is, you can just swap those two around. It's really that simple, that configurable. But I hope you guys have found this video useful and it's given you some ideas of what you can do with these new custom OSD elements. They're really powerful, really useful. Sorry, I forgot one thing. At the moment, there are some limitations in what is displayed with regards to values. The reason is it was using the wrong integer value in the programming tab. So there's a bit of a limitation. You'll get up to a certain point and then the value will stick. In the release of INAV 8, that will be fixed. So while testing in hardware in the loop, I found that the altitude got stuck at 320 something meters. It wouldn't go above that, but obviously below that it was fine. And it is because of this integer value. It only goes up to that 32,000. In INAV 8, it goes above and beyond that, so you'll be absolutely fine. I just wanted to make you aware of that. So if you see a number getting stuck, so there are a couple of things that it affected. It affected get flight time, get distance to home, get total distance traveled, airspeed estimate, actual position Z, which is the altitude, vertical speed, and 3D distance to home. They were all limited with an integer 16 where they should be integer 32. So that is fixed in INAV 8. So if you notice any of those values get to a number, if you notice it getting stuck around that, that's the reason behind it. And it will be fixed in INAV 8. So don't worry too much. If you see that, it's not something that you've done. It's something that's going to be remedied in the next release. So thank you guys for watching. I hope you enjoyed the video. If you did, please give it a thumbs up. Don't forget to click for subscribe and the bell icon. That will help get this video out to more people too, so they can learn how to do this. Why not? It's cool, right? Also, when I produce more videos, you'll get an alert. Maybe it's something else that will interest you. Thank you very much for watching, guys. Enjoy your summer. Fly models like you stole them. See you on the next one. The next one, again, you select the global variable. It will be free integer digit. It will be free integer. It will be free integer. Fucking hell. It will be free integer. It will be 3 integer digits followed by 2